Welcome to this How Do I video on setting up a Microsoft Dynamics NAV server with an Azure load balancer. In this video, I'm going to demonstrate how easy it is to set up an internet-facing load balancer to distribute the load to your NAV web servers across virtual machines. The following figure shows a load-balanced endpoint for web traffic. That's the public IP address. The endpoint is being shared by two virtual machines that are part of an availability set. Each machine is running the NAV web client and the NAV server, and the NAV servers are connected to the same Azure SQL database, as I demonstrated in my previous How Do I video. Here are the steps we're going to go through today to explain how this works. You might be thinking, why would I want to use an Azure load balancer? Well, the Azure Load Balancer will help you provide availability for your clients with NAV servers that are running in Azure virtual machines. Availability means failover. If one or more NAV virtual machines in the availability set needs to be stopped for maintenance, then the load balancer will automatically direct the clients to another virtual machine in the availability set. The load balancer makes it easy to distribute the traffic because none of the clients need to know which machine they're actually connecting to. Scale out is also possible. If you have many users on a single NAV instance, you may want to distribute the load by adding more virtual machines to the availability set. The load balancer distribution algorithm will ensure that clients are distributed to different virtual machines. However, there are some issues with the distribution of clients for NAV that I'm going to discuss later. I would also like to mention that this is not the only way of load balancing NAV servers, and there is a white paper available on PartnerSource which describes this topic in depth, including how to set up application request routing in Internet Information Server. There is a link to the white paper at the end of this video. So here's what the load balancer does. It's quite simple. There's a public IP address and domain name, and then the load balancer distributes requests for that public IP address to the three virtual machines that are hidden behind in a virtual subnet. It can be configured to direct internet traffic to any of the virtual machines, and it can also, using port forwarding, forward specific traffic to specific virtual machines. And this will enable you to create, for example, RDP connections to the virtual machines that are behind the load balancer. And here's how the NAV virtual machines are set up for load balancing. So firstly, you need to create a resource group when you're deploying your virtual machines, and that's part of the new Azure resource deployment model. You have to add the machines to an availability set, and then you have to configure a virtual network with the virtual machines together in a what we call the backend subnet. Now, I've created a script which does all this for you. I've created a link to that script from my blog, and I've got a link to that blog at the end of this video. So I'm not going to go through running the whole script and showing you here today because it takes some time. Once you've configured the load balancer and the virtual machines, then in order to use them in the way I'm demonstrating here, you need to run the script to initialize the demonstration environment and also to use an Azure SQL database. And then once you've got the first machine set up, then you basically connect the other machines to the same Azure SQL database. So just to explain availability sets, when you place multiple virtual machines in an availability set, Azure ensures that at least one of the machines must be available. It does this by making sure that they're not updated at the same time, and it also ensures that they're not put on the same hardware cluster, so there's not a single point of failure for those machines. So here are the components of the Azure Load Balancer, and I'll walk through them by looking at the Azure portal. So let's switch to the Azure portal. So I'll start at the dashboard here, and I've created a link to my load balancer, which is part of my resource group. And here you can see the settings of the load balancer. There's an IP address, which is the public IP address, and it's being shared by all these different ports here listed. There's the rules which are set up. And you can see here the rules for the various endpoints that NAV uses on the standard demonstration environment. So there's the HTTPS for the web client, and the Windows client 7046, and also the help and OData here. If we look into them, each of them is defined the port mapping on the external and internal, so you can use different port numbers internally if you want to. And you also define a health probe, which determines whether the availability, we'll look at that in a minute, and also the session persistence, we'll also look at that, how that works in a minute. The other thing to set up is the health probe. In this case, it's a very simple probe which is set up to look at the default page, which is the demonstration landing page on port 80. So the load balancer uses that to determine the availability of the virtual machines inside the availability set, and you can control the interval for it probing and how it determines failure. Finally, there's the NAT rules which you can set up, and this determines how you can go to specific machines, in this case for RDP, so it's set up a specific port number which maps to the RDP port on that machine. So they're the components of the setup of the Azure Load Balancer, and as I said, this can be done with a PowerShell script which I've linked to. So failover works because the health probe is always polling to see if the machines are available, and the health probe, if it detects that a machine is not responding, then it directs it to one of the other instances that's available. So here's a diagram just showing how that works simply. So showing here that if one of the machines has failed to respond, it starts directing traffic to other machines. So that's basically how the availability part of the load balancer works. So how does the distribution of load work? Well, typically by default, Azure will distribute the load per TCP connection, and that's based on the IP address and the ports. That won't provide, it'll only provide stickiness of the connection within a TCP session, and that's not enough for our NAV clients because they need persistence of sessions over a longer period of time, like for the whole client session. So we need to use some other configurations, and we can look here at how that can be configured, and this is using the setting which I showed you before on the load balancing rules, which is to provide source IP affinity. So this means that the same requests from the same client will go to the same server, of course, if that server is available. And this will ensure that the NAV web and Windows clients will continue to connect to the server where the session exists. So just to recap on that, and let's remember that web servers and OData, they can be stateless and therefore could be distributed over many instances. Web and Windows clients have persistent session on the NAV instances, and they need to have session affinity, which means the requests need to be distributed by IP address and protocol. So let's see how that looks. So as we showed before, on the load balancing rules, I've got OData here, and the session persistence is none. It can use any session. If we look at the NAV rule and the HTTPS rule, they both have this client IP and protocol session persistence. So if I look at my active session table here at the moment, I can see by looking at the database that I've got sessions on different instances. I've got one session which is a OData session connecting to this machine demo 02, and the other two sessions are on demo 01. So if I go to the web browser again, you can see here on port 80 I've got connected to the landing page, and in one instance it's connecting to 01. I've actually modified the landing page so I can see which instance I'm connected to, and in this one it's connected to 02. If I, for example, open up the client here, which is the Windows Store or tablet client, then you can see now another session should be created here with that, but they're all now collecting to 01, so this changes all the time. For the purpose of the demonstration, I've created a test that connects to the OData service from different geographical endpoints. This is done using Visual Studio Load Test, and I'll demonstrate that in the next How Do I video. But for now, I can just show you that the OData connections, of course there's many of them, we can see them in the session event table. So as we query the session event table, we can see the connections are switching between the two server instances, 30 and 28 here. And that just shows that it's distributing the requests across the two internal servers. So let's go recap the topics we've covered today. Firstly, we talked about how the Azure Load Balancer works. Then we talked about how to configure the Azure Load Balance to work with Dynamics NAV servers. And finally, we talked about how the Load Balancer provides both failover and load distribution to your NAV servers. There are some limitations to this, and we'll be exploring that in the next How Do I video, where we demonstrate load testing against load balanced NAV servers. So here are some useful resources. Firstly, the Azure documentation has a great overview of the load balancer and also a good walkthrough on how to create an internet-facing load balancer using the resource manager. The information in there, I've built a script in PowerShell based on that information, and I've written a blog post about that script, and I've also made the script available there on that blog post. And finally, on PartnerSource, there's a white paper which discusses all the options for large-scale hosting and load balancing of NAV servers on Windows Azure. So that's definitely worth reading. This video was created in collaboration with Microsoft and the Training Center Platan. Thanks very much for watching.